Welcome to Microsoft's training video series for font developers. This video presents information on hinting Indic script fonts. This step-by-step guide will teach you how to apply hints to an Indic font using Microsoft's Visual TrueType tool. This advanced training series is geared for individuals with experience in TrueType font development. What is hinting? Hinting is information included in a font file which a rasterizer uses along with the glyph outlines to determine which pixels to turn on and off when the glyphs are displayed on screen at certain sizes. Hinting controls distances, proportions, and pixel patterns of glyphs. Hinting greatly increases the readability of a font at small point sizes, especially on a low-resolution screen and other devices with fewer dots or pixels. Why is hinting necessary? When an outline is scaled to small sizes on a low-resolution screen, there are very few pixels available to describe the shape. Without hinting, heights and weights can become inconsistent. What can hinting do? Hinting applied to an outline can control the alignment to maintain consistent heights, weight to make stroke weights consistent, glyph shape to prevent rounding variations, symmetry to make strokes and counters symmetrical, spacing to maintain space between the glyphs so they don't crash or have too much space, and design. Hinting can also help to preserve the integrity of the true outline. On this unhinted G, the right stem is 2 pixels wide while the left stem is only 1. Hints applied to the G are used to keep the stem weights consistent. Hints are also used to align the top height and the baseline. Unhinted strokes can sometimes appear too bold, especially at small sizes. Hints can control when the stems will go to 2 pixels. Hints can also be used to control the shape and position of marks, which is important in distinguishing the correct glyph shape. Hints can also be used to control overshoots or when a round height would extend beyond a flat height. In this example, hints are used to prevent the left part of the outline from extending beyond the right at small sizes. Once again, hints are used to control heights, stem weights, overshoots, and in this example, making the glyph shape symmetrical. Microsoft Visual TrueType is a professional-level graphical tool for viewing, editing, and adding instructions or hints to the outlines of TrueType and OpenType fonts. This visual tool allows you to manually apply hints to an outline. The tool is available for both Windows and Macintosh platforms and can be downloaded from the Microsoft website. See the appendix of this video for more information. Hinting relies on properly marked outlines. Heights and weights should be consistent. Any mathematical differences should be there for design purposes and not because of poor outline design. For example, if you have a straight line, the marking points or nodes should be on the same coordinates. In this example, the point on the right should also be set to 1160. Even a few units difference could cause part of the outline to round to the grid differently. The extreme edge of a curve should also be marked, as these are critical to hinting. While you can edit outlines in the Visual TrueType program, it is better to use an outline editing tool such as FontLab. Remember, time spent cleaning up the outlines will make the job of hinting easier and faster. When you first open VTT, the default setting should open the following windows: the main glyph window, the work area where you will create the hints, the character set window, which shows all the glyphs in your font, the Control Program window, where the CVT values are entered, the VTT Talk window and the Glyph Program window, where the hinting code is stored. The Pre-Program window and the Font Program window should be minimized. In this demo, we will not be editing these tables. Let's review the toolbar in VTT. Starting at the left, we have the viewing tools: Navigate, Zoom in, Zoom out, and the measuring tool. When grid fit and pixels are turned on, the measuring tool will measure the number of pixels. When they are turned off, it will measure the distances in the outline. The next four tools are the control point tools: Move Point, Swap Point, Delete Point, and Add Point, and they're only visible when grid fit and pixels are turned off. The hinting tools are Angle, X-Link, Y-Link, X and Y Shift, X and Y Interpolate, Stroke, Align, X and Y Delta, and X and Y Move, and these are visible when grid fit and pixels are turned on. VTT lets you display the hints for X or Y direction or both. This makes it easier to focus on one direction while hinting. The final tools are the camera tool, which can take a snapshot of the main window and is useful when hinting like glyphs for comparison, the Change Back tool, and the Size Run tool. Under the Tools option menu, VTT allows users to change settings and set preferences for things like glyph appearance, size runs, and extra text. These settings can be changed at any time and take effect when you close the dialog box. For example, Show Fewer Points hides the off-curve points, which we don't need for general hinting. Other options under glyph visuals can be turned on and off in this palette or can be selected directly from the display menu. The options for grid fit and pixels will be used often while hinting, and VTT has set up quick keys for these: Control G and Control B when you are in the main view. We will keep the default appearance settings for this tutorial. Also under the display menu is the setting for the device resolution. This is the resolution of the intended output device and determines the number of pixels available for displaying any glyph. This setting is important, so make sure you set it correctly for your font, setting the lowest screen resolution your font will be used on. If your font is hinted well for the lower resolutions, it should also look good at higher resolutions with more pixels. More menu options will be discussed as we begin hinting. Open your font in VTT and select Prepare Font from the Tools menu. The dialog box will give you the option to remove any existing hints. Some font programs may apply auto hints which VTT cannot use. Prepare Font imports templates for the following tables: the Control Program table, which stores values or CVTs you enter to control the regularity of features. This template is imported with various default settings for when hinting is turned on and off, dropout control, and entries for common typographic features for heights and stem weights. Prepare Font also imports the Pre-Program and Font Program tables. These store preset values and functions. Note with VTT 4.2, it is no longer necessary to edit these tables directly. Most of the information you need can be entered directly into the control program. Character group data is also imported, and this text file can be edited to enter additional character groups, or data that is used by VTT when assigning CVTs. The control program template imported when we select Prepare Font includes instructions for setting up the program. and certain default settings and entries for common features for Latin-based fonts. The font developer needs to simply take measurements, enter the values, and decide on which features to be used. However, for other scripts, such as Indic, you will need to create new features in which to enter the Indic CVT values. Note, in the control program you can comment out text by using an asterisk, slash before and after the text. Any text between these will be ignored by the VTT compiler. To begin, let's create a new group for Indic. This can be entered anywhere at the start of the control program. When changes are made to the control program, the table needs to be recompiled. VTT has an option for compiling under the Tools menu, or simply type Ctrl-R. The main use for CVT values is to 1. Control pixel heights by aligning glyphs to height and baseline CVTs, and 2. To control the pixel widths of stems by assigning CVT values. Let's start with the heights. For Latin, as the features have already been set up, we can go into the main view and take some measurements. Well, starting with the cap H, we notice the height is 1518 and our baseline is 0. We will enter these values in the control program. Returning to the main view, we will select the cap O to find the overshoot. We see 1544 and minus 26. In the control program, we will enter 26, which is the difference of the cap flat height to the round height, and minus 26 for the bottom of the O. Note that value in CVT3 is made relative to CVT2, and CVT9 is made relative to CVT number 8, meaning VTT will use these values until a certain ppm range. The default setting here is 42. Now let's create some entries for Indic. We will need to start with the next available CVT, which is easy to determine by the number in the title bar on the control program. Since 120 entries already exist, we will start with CVT number 121. Let's enter features for flat heights as well as round heights. Return to the main view and select an Indic letter. From the Edit menu, you can choose Go To Glyph and enter either the glyph name or Unicode value. Now let's take a measurement of the top of the Indic Ka, which we see is 1320, and the baseline is 0. Go back to the control program to enter these values. Now we will choose another glyph that has an overshoot or a round height. Take a measurement from the flat height to the round height, and the difference is 61. And the bottom is minus 40. Remember, we want to make these relative to the flat heights, using the same syntax that was used in the Latin. We want to make CVT 122 relative to CVT 121 and CVT 124 relative to CVT 123. You can create as many height CVTs as needed. Always create a complete set of CVTs for each script in the font. Although the second script may share the same zero baseline or perhaps some of the same stem widths, it is recommended to create additional CVTs for various reasons. First, it is easier to manipulate glyphs belonging to a certain group. For example, if you wanted to change stem widths of the Latin only, you may not want other glyphs referring to those CVTs. In addition, if you later want to merge different scripts into different fonts, having a separate set of CVTs makes it easier to export and edit. In the same way values are entered for the heights, we then go through and enter values for the stem widths. Again, the control program template has already set up CVTs in which to define the stem widths for Latin. Attributes for entries like character group, link color, link direction, and feature category have also been defined. Let's begin with the X straight stems for Latin. Return to the main view to take a measurement. We can measure the stem width going through all of the like glyphs to get an average. We will enter the value in the control program. We can move on to the X round strokes in the uppercase Latin. Again, you should go through all of the similar glyphs to get an average. Notice the use of equals. Here we are making CVT 70 equal to CVT 68 until 100 ppm. We will discuss the use of inheritance in the next section. Before we create new CVTs for the Indic, notice that we have not compiled the window after adding the Indic heights. Hit Ctrl R to recompile. Create the Indic entries in the same way as the Latin was done. Let's start by taking some measurements of the X straight strokes. You would want to go through all of the like Indic letters to measure the stem width and create a CVT value. We'll take the average of 176 and enter that in the control program. You can set additional CVTs with a placeholder of 0. We'll move on to the round strokes, returning to the main view to take measurements. In going through these, we notice we have two very different measurements of 159 and 173. We will use both values. Let's compile the window and move on to add the features for the Y direction. Continuing on, measuring the round strokes. It is important to measure all of the stems in a character group and take an average for the CVT. If the difference is greater than 5 units, you may wish to create an additional CVT. CVT values should be created for all stem weights that are repeated. For Indic fonts, that might include base glyphs, pre- and post-base forms, vowels, marks, and punctuation. Inheritance is used to control stems within a group and groups within a font. Inheritance is created in the control program directly when a CVT is defined. It is the method of making a CVT equal to or relative to another CVT. When a CVT is relative to another CVT, its value refers to the first CVT plus the overshoot or undershoot amount, starting at a set ppm range. For example, we entered 1320 for our Indic flat height and 61 for the round height. We used relative inheritance, making 123 relative to CVT 121. We can see at small sizes the pixel height of the round is the same as the flat height. When we go higher than the 42 ppm, we can see the overshoot as the round is now 1 pixel taller than the flat height. What if you wanted your overshoot to turn on at a smaller size, like here at 24 point or 32 ppm? We can go back to the control program and change the 42 to 32 and recompile the window. Now you will see the overshoot has turned on starting at 32 ppm, but it does remain the same height below that. When a CVT is equal to another CVT, its value refers to the first CVT until a set ppm range is reached. For example, when we entered the stem weight for the Latin round, we made it equal to the straight stroke until 100 ppm. This is to prevent the round strokes in a glyph from going to 2 pixels before the straight stroke. Let's go to the Indic CVTs. We have not used inheritance yet. We have 2 round strokes of 159 and 173, and a straight stroke of 176. Going back to the main view of the hinted Ka, starting at 10 point, all strokes are 1 pixel. However, when we get to 14 point, we can see that the straight stroke goes to 2 pixels, as does one of the round strokes, but one round stroke remains 1 pixel. We'll go back to the control program and use inheritance. We'll make both our round strokes equal to the straight stroke until 100 ppm. We may go back and change this size after hinting more of the glyphs and comparing to any other scripts that might be in the font. Compile the window and go back to the cut to see what happens. Now we'll see the other round stroke is also 2 pixels. Once key glyphs from the major character groups have hints, you can compare the thickness of stems and make corrections. For example, if you have Indic and Latin glyphs in a font, you may want them to have the same pixel weight at small sizes. If the Latin stems become 2 pixels before the Indic, it may appear the Latin letters are bold when used with the Indic. For Latin, you should also make sure that the lowercase and uppercase go to 2 pixels at the same size. In addition, global inheritance can be used to control the X and the Y stems. VTT has set aside 3 CVTs to control these global values, CVT 65 through 67. CVT 65 is reserved for the main CVT of the thinnest stem in X and Y, used to maintain at least 1 pixel so the stems do not collapse. After the stems are allowed to expand to 2 pixels, CVT 66 is used to control the X stems and 67 for the Y stems. These CVTs are defined using the syntax of equals until a specified ppm size. Compare all stem weights for the Indic and the Latin and take an average value for the smallest stem. We will use 150. Now take an average of the X stems for CVT 66 and the Y for CVT 67. We're going to use 176 for both, which in this case is our Indic stem weight. 17 ppm is the default size at which most fonts transition to 2 pixels. Recompile the program. After creating the parent CVTs and compiling, we will need to assign inheritance to our Indic X and Y stems. Note the default setting in the control program has already assigned them for Latin, 66 for the X strokes and CVT 67 for the Y. And for now we'll keep the default ppm size. Moving on to the Indic, let's assign the X straight stroke CVT to 66 and the Y to 67. Notice our round strokes in the Y direction have inheritance yet. We should refer CVTs 131 and 132 back to CVT 130. This will keep the Y strokes for Indic consistent. Compile the window to see the results. Remember, before using inheritance, our Indic stems were at 1 pixel while the Latin went to 2 pixels at 13 point. After using inheritance, we keep them both at 1 pixel. And notice 14 point, where our X and Y stems are inconsistent. Making stem weights the same at all sizes, or small sizes, is critical to legibility on the screen. Before we begin hinting, let's review the character group settings. VTT uses character group data when assigning CVTs. There are 2 ways to assign a character group. Edit the character group text file that is imported when we select Prepare Font. This file is found in the VTT program folder, and it assigns glyphs by Unicode value to a character group. Or we can assign a glyph to a group in VTT by selecting the menu option Edit Character Group or Ctrl-U. For example, the default setting has this Latin cap H assigned to the group uppercase, and the lowercase Latin h is assigned to the group lowercase, and the numbers are assigned to the figure character group. Since Indic letters are not pre-assigned in the default character group data file, it will be assigned to any group. We will have to change this before we begin hinting. To open the character group data file, use Notepad and open the file found in the VTT folder. In the file there are instructions on how to add a new group to the list. If you make changes here, you would have to re-import the character group data file into VTT using Prepare Font. For this demo, we will assign the character group for each Indic glyph in VTT. Remember, we already created the setting for the group Indic, and we use the Indic setting to create CVTs for Indic heights and Indic stem weights. To change the character group in the main view, type Ctrl-U until you reach the correct group. While there are many strategies for achieving a well-hinted font, a good workflow is key. Remember, prep work in hinting is very important and can be as time-consuming as the actual glyph hinting. After running VTT Prepare Font, we take measurements, create CVTs, and hint a few key glyphs from each group, or script. Compare heights and weights, and assign inheritance. It is easier to hint in one direction at a time, and VTT can limit the display to X or Y. We always anchor or link control points before interpolating, and review spacing and make adjustments if necessary. Since we entered CVT values for the Indic heights, most of the anchoring will be done using a CVT. To begin, let's select the hinting tools. Ctrl-Shift-Y will turn on the Y tools. Right-click on the point you want to anchor. VTT will search the control program under Indic heights. Here it is selected CVT 121. Right-click the point at the bottom, and this will select CVT 123, our Indic baseline. Moving on to another glyph, right-click the point, and again, and here CVT selects 122, which is our Indic round height. And 124 for our bottom, and 123 for the zero baseline. Let's move on to a Latin glyph. Right-click the point, and VTT selects CVT number 2, which is the Latin cap height, and CVT number 8 for the Latin baseline. If you choose a lowercase glyph, VTT will look in the control program under CVTs for lowercase. You can see that by using glyph groups, VTT can select the correct CVT value rather quickly. If you want to change what VTT has selected, simply click on the value and scroll to the desired CVT. For points that do not have a CVT value, like a middle stroke, we will interpolate those between the anchors later. When we right-clicked over a point to anchor it, VTT displayed a menu for rounding options. This rounds the control point to the grid. VTT gives you 6 options for rounding a point to the grid, and will automatically select rounding for anchors and links. For this demo, we will only be using the top row and not the bottom 2 rows for italics. For anchoring a CVT, we use the Round to Grid option. The rounding menu is available for both X and Y hinting. The first option, No Rounding, will not move the control point on the grid. The second option, Round to Nearest Grid, is used when we anchor to a height CVT. The third and fourth options, Round to Half Grid and Round to Double Grid, are used when interpolating a point. Round down to grid will round the point down to the nearest grid, and round up will round the point up to the nearest grid. We will further review these rounding options later in this tutorial. A link connects 2 control points over a flexible distance. It starts at one point, the parent point, and ends at a second point, or child point. The link doesn't affect the parent point, but it does determine the location of the second or child point. More than one link can start from the same point. Links go in one direction, so the toolbar has 2 linking options, one for X and one for Y. You can use links with CVT values or without, which is called a distance. Links that are used with CVTs for common distances, like stem weights, are entered into the control program. Using links for unique distances with no CVT value works in the same way, linking a parent to a child point. You can also set a minimum distance to force it to maintain 1 pixel or more, or allow the distance to collapse. Let's review the X and Y link tool options. The column on the left, marked in yellow, are the options for a link with no CVT value. The top row of options are for links using a CVT value. The symbol in the middle row tells VTT to maintain a minimum distance of 1 pixel. The symbol in the bottom row tells VTT to let collapse if the distance is not great enough for 1 pixel. The 3 link shapes available tell VTT from which category of CVT to select from in the control program. The first is any CVT, the second with the flat top will select from the straight stroke CVTs, and the third with the round top will select from the round stroke CVTs. Let's create some links and distances. Click on the Y tool, click on the anchored point, and drag to the other side of the stem. Right-click the arrow and select the straight stroke CVT option, the one with the flat top. Click again on the anchor and drag to the other side of the stroke. VTT will always use the last option selected. Let's use a distance to this next stroke. Click on a hinted point and drag to the next point. Right-click the arrow and this time select the distance tool that will maintain at least 1 pixel but no CVT value. Now we can create a link for this Y stroke. Right-click the arrow and this time select the rounded tip arrow, which will select from the round stroke CVTs. We can do a distance to the stroke on the other side. Right-click the arrow, and this time we'll use a distance that does not have to maintain 1 pixel, and create another link using the round stroke CVT. Use another distance to the bottom stroke. Again, link it using a round stem CVT. Note, there are several ways to hint this glyph, and you can test different methods for the best results. Interpolation is the method of interpolating or inserting between one or more points between 2 parent points. Interpolation does not preserve a set distance, but it preserves the proportion of distance between parent points in pixels. Let's go back to the cuff. Previously, we used a distance for the middle strokes. However, we could also interpolate them between the top and bottom anchor. This may produce better results, especially at small sizes. Select the Y Interpolate tool, click on the top anchor and the bottom anchor. Grab this line anywhere and drag to the point or points you want to interpolate. Just as we can interpolate strokes between anchors, we can also interpolate a point within a stroke. clicking our two anchor points and dragging to the points that fall between them. Note, if you try to interpolate a point outside of the parent points, VTT will give you a warning. Let's hint another Indic glyph using interpolation. First, we need to create our links. Remember to right-click the arrow to select the correct option for the round or straight stroke CVT. Here you could use a distance to this point. And again here. Create a link for the straight stroke, and don't forget the other side. Now we can interpolate the middle strokes. Select the interpolation tool, click on the top and bottom anchor, and drag to a point on the middle stroke. You'll need to anchor the point and create the link. Let's take a look at some rounding options we might use when interpolating a point between the points on a stem. In this example, at this point size, the use of no rounding works well. But let's look at larger sizes. If we try a different rounding method, such as round to half grid, this will always get the control point on the center of the pixel, but not necessarily in the center of the stroke. Here, the round to double grid option has the same results at this size. You should check other sizes. At larger sizes, we see that the round to half grid is our best option. Select the rounding method that works best when interpolating a point in a stroke or when interpolating a stroke between the anchors. So far we have only hinted in the Y direction. Let's turn on the X direction tools and apply some hints. You can change hinting directions from the display menu or by typing Ctrl-Shift-Y or Ctrl-Shift-X. In Y we had CVTs for heights and widths, but in X we only use CVTs for stem widths. While hinting, you may have noticed VTT has automatically generated code in the VTT Talk window. You can see this code and the Y hints that we have applied. For advanced users, it is possible to type directly into this window and compile the code. This code in turn generates the low-level TrueType code in the Glyph Program window. In Indic Fonts, where the base letters connect at the top, we need to make sure the outline and the pixels go to the edge of the side bearing, or width of the character. Select the X-Link tool and right-click to anchor the left side of the bar. For the right side, we can create a distance from the advance width to the right side of this top bar, using a distance with 1 pixel minimum. This will ensure connections at all sizes. We could also create a distance to the right stroke. And here we could select the less than 1 pixel option to allow the distance to collapse if it's not great enough for 1 pixel. Do the same on the left stroke. and create the links. Right-click the arrow to select the correct option. Next, we can interpolate the stroke in between. Select the X Interpolate tool and click on the anchor points. Click the graphic in the middle and drag to a point on the stem to be interpolated. Anchor the point and create the link, using the CVT for the straight X stroke. You can use a distance to the top part of the stroke and create another link. Don't forget the middle part, and a distance will work to align this point. Remember, there is more than one way to achieve the desired results, so always check a range of point sizes. We can interpolate this point here without rounding. Let's try another glyph. Anchor the left part of the top bar and use a distance for the right. You could also use a distance for this stroke. Create the link, then we can interpolate the other strokes. Anchoring and creating links. Remember to always click on the arrowhead to make sure you've selected the right CVT. Shifting control points. The Shift tool creates a rigid relationship between 2 points. It tells Visual TrueType to maintain the same relative distance between the first parent and the second child point. A shift differs from a link in several ways. A shift doesn't use control values. It does not need to be rounded to the grid. It doesn't have to move the child point in full pixels, and a shift does not default to the 1 pixel minimum used by a link. Shifts are appropriate when the distance being controlled has no CVT entry and the distance is very small and will only become a full pixel at large sizes. Let's look how a shift could be used. Anchor the sides and use a distance to the left bowl. A distance could also be used to the bottom bowl, or you could try a shift. Select the Shift key and click to the point. Notice the shift does not automatically round the point to the grid, which you may want to do before creating a link. However, there are times when not rounding produces better results. Spacing is key to readability, especially at small sizes. Side bearings of glyphs are controlled by hints in the X direction. This can be done using a distance or creating a link with a CVT value. These distances or CVT entries can then be adjusted at different ppm sizes, giving you control over the spacing. It is important to have at least one pixel of white space in between the glyphs for legibility. A text string of key characters can be set up to check the spacing. For example, on the ka, we use the link tool, creating a distance for hinting the glyph in relation to its width. A CVT could also have been created. This works best for scripts where glyphs have many similar side-bearing values, such as Latin. For example, here on the cap H, the distance on the left and the right side bearings may be similar to that of other Latin uppercase, and a CVT could be created with the value of that distance from the outermost point on the glyph to the side bearing. The same for the round distances. When you turn on the text string, you will see that it is set up for Latin glyphs. However, for other scripts as Indic, a new string can be created in the control program. The control program gives instructions on how to add these key glyphs. First, find the character group we defined for Indic. Here, you can type in a few Indic glyphs by Unicode value surrounded by the tilde. A space will be replaced by the current glyph in the main view. Surround your list with quotes. When you're finished, make sure to recompile the window. Returning to the main view, you can now see the Indic glyphs that were entered along with the current glyph in the main view. You can check through various point sizes to adjust the spacing. Always hint your key glyphs first to check the others. After hinting a glyph, review all ppm sizes likely to be displayed on screen. If a particular size does not look good, you may want to adjust its pixel pattern by adding a delta. A delta is used to manipulate pixels in a glyph by moving a control point a set number of pixels, whole or fraction, at a set ppm size. The delta tool is available for both X and Y hinting. When you click on a point, this delta menu appears. The move can be made in fractions of pixels and can be applied before or after other hints on the glyph. These options can be accessed by pressing the Shift key while in the delta menu. The three options are as follows. An inline delta moves the point after incoming hints but before any outgoing hints and affects all subsequent hints. This works well for adjusting the position of an entire feature. A pre-delta moves the point after incoming hints and outgoing hints have been applied, but before VTT smooths the outline. This can be used for adjusting the weights of features without affecting subsequent hints. And a post-delta moves the point only after VTT has applied all the other hints and smoothed the outline. This approach works well for adding or deleting individual pixels. Let's try a few deltas. Back on the ka, we can scroll through different point sizes using the arrow up and down key. On black and white hinting, deltas are most helpful when the stems are only 1 pixel, before grayscaling is turned on. Notice the bowl on the left at 12 point compared to the bowl at 13 point. Let's try an inline delta to make this bowl 1 pixel smaller in the X direction. Turn on the X tools, Ctrl-Shift-X, and select the X delta tool. Click on the point and use the Shift key to select Inline and drag it to 1 pixel. Look at the delta in the VTT Talk window, and you will see that it comes in line before the link. Move point 47 1 pixel at 16 ppm. Now let's try a pre-delta. Turn off the X tools and turn on the Y tools. Select the Y delta and click on this point. Use Shift to select Pre and move the point only a fraction at a time until the desired results of turning this pixel off. You can do the same on this point. Notice where the pre-delta information is stored in the VTT Talk window. Finally, we can try a post-delta. At this size, we may want to turn off this pixel here. Let's show the off-curve points on this outline. Select Display Options from the menu and click Off under Show Fewer Points. Now we can delta an off-curve point. Turn on the X tools and select the Delta tool. Note, if you attempt to create a pre- or inline delta on a point that has not been hinted, VTT will display this error. Post deltas are the only deltas that can be done on unhinted points. Change this delta to a post. Notice this delta comes after the smooth in the VTT Talk window. Remember, each delta increases disk space and memory in the font. Applying a delta to the same point at several sizes usually indicates a need to change the base hints or grid fitting. You can also apply a delta to a CVT by entering it directly into the control program. These deltas can be used on height CVTs to adjust a height at a certain size or range of sizes. A delta can also be used on stem weights to reduce or add a pixel at a certain size. Going back to the CA, take a look at how the height CVTs are rounding to the grid as we step through different point sizes. You may decide to change the height at one size or another. For example, we notice that 11 point, where it is rounding up to the grid, may appear too tall. We can reduce this height by 1 pixel by adding a delta to the CVT just for this size. Go to the control program and find the height CVTs for Indic. Type in as follows: delta -1 at 15. Recompile the window and watch the height of the CA as it is reduced by 1 pixel. Note, this will affect all glyphs referring to this particular CVT, and it will in turn affect the round height CVTs which refer to this flat height CVT. Adding a delta to a CVT has a much broader effect than adding a delta just to a point. If you decide you want to add deltas to a height or stem weight, you should consider the results carefully, especially if you are using inheritance. A delta moves a marking point a set number of pixels and applies to only the ppm sizes you have set. A move will also move a marking point but applies to all ppm sizes. Moves can be useful for improving the step pattern of pixels on diagonal strokes. For example, here on this letter E, after going through several sizes, we may decide to turn off this pixel here. Instead of a delta, let's try a move. Turn on the Y hints and select the Y move tool. Click on the point, and like the delta tool, you can select fractions of a pixel and when to apply the move. In this case, we'll select the inline option. Check various sizes to see if it produces the desired results. In the VTT Talk window, you'll notice no specific size is set, as a move applies to all sizes. We see move 1/4 of a pixel, point number 13. Composites are glyphs that reference more than one character, like a base glyph and a diacritic. The advantages of using composites are many, including hinting. Just as composites use the outlines of the original characters, it also uses the hints, therefore saving time. For example, this composite glyph for the ka nukta would use the hints from the ka and from the nukta. Therefore, no code is in the VTT Talk window. However, code is automatically generated in the glyph program. Use My Metrics tells the composite to use the width and side bearings of the first composite part. The next line with the offset shows glyph ID 128, which is the ka, and the zeros are used for no offset, keeping the base glyph in the same position. Glyph ID 80 is for the nukta, and this code is telling it to offset this glyph 1418 in X and 148 in the Y direction. Additional code may be needed to control the placement of one or more of the composite parts. VTT uses two functions for controlling the position of composites in X and Y. Generally, in scripts where the base glyph is not moved, only the accent or mark would need to be adjusted using this function call. The two functions set up for composites are function 80 and 79 for controlling the X and Y locations, and are typed directly into the glyph program and compiled. Function 80 is used to adjust the composites in the X direction, for example, to center a mark over a base glyph. Function 79 is used to adjust the height of the composite, for example, to keep the mark's pixels from crashing into the base. To see how this works, let's center this mark over this base glyph. We will enter the code in the glyph program. The function 80 call starts with offset 0, points 26 and 18 are on the mark, and 16 and 17 are on the base. The next line tells it to shift contour number 1. Function 79 also starts with the contour number, then a point on the base followed by a point on the mark. Compile the window to see the results. To view your hinted glyph in grayscale, select the option from the display menu, or Ctrl-Shift-G. Grayscale gets turned on in a font according to the settings in the GASP table. In VTT, you can edit the GASP table and set the ppm sizes for when to turn on grayscale, grid fit, or both. Select Edit GASP Table from the Edit menu. Grayscale is usually turned on around 17 ppm, or when the stems go to 2 pixels. Here it's 18. At smaller sizes, the grayscale may look too fuzzy, so this range is only grid fit. but at very small sizes, for example under 8, when too few pixels are available for accurate grid fitting, grayscaling may produce better results. You can also view how your hinted font will appear in ClearType by selecting it from the display menu, or Ctrl-Shift-C. A well-hinted font should translate well into ClearType. However, there are additional hints or function calls that can be used. What is most important for ClearType is the hinting in the Y direction for heights and horizontal strokes, as the vertical strokes will be rasterized with color. See the appendix for more information on ClearType. VTT allows you to import a glyph into your font. This is helpful if you need to change the design of an outline or add additional glyphs to the font. Import a glyph option can be found under the File menu and has the following options. You can import a single glyph or range of glyphs. You can overwrite the current glyph or append the glyph or glyphs to the end of the font. The overwrite option replaces the current glyph with the outline of a glyph from another font, plus all of its hinting if it is hinted in VTT. For example, its current VTT Talk and Glyph program. Be aware the hinting code from another font may need to be changed to match your current CVTs. The append option imports a glyph or range of glyphs to the end of a font, including any VTT hints. Note, VTT will not update all of the table information or import things like Unicode values or glyph names. Therefore, those tables will need to be updated. Sometimes you have to force pixels outside the actual outline of a glyph for legibility. While this can be useful, be aware of clipping. Fonts are designed with ascender and descender values and appear in VTT as blue lines, and when pixels are forced outside these values, they may be clipped or not displayed at all. We often hint combining marks in isolation. However, we must keep in mind they will be placed over or under a base glyph, which usually has a limited number of pixels of available space. This is especially important at small sizes. If you have stretched the hinted outline of the mark too much, it may be clipped when placed on a base glyph. A VDMX table should be calculated for a hinted font. This can be done with Microsoft's Cachette tool. VDMX heights can be shown in VTT through the display menu and appear as green lines. Forcing pixels outside of the VDMX can cause clipping and/or scaling. After you have hinted all glyphs in your font, you should recalculate the max P table, which may have changed during the hinting process. Select Recalculate Max P from the Tools menu. This will run through all of the glyphs and reset the global maximum value. After, make sure to save the font. Next, you can run Ship Font from the Tools menu. This will strip out all ASCII text tables from the font, leaving only the necessary data. Always save this font with another name and do not overwrite your source font. Only the source font can be edited in VTT. If after testing you need to make changes, always change your source font and regenerate a new version of Ship Font. Thank you for watching this video presentation on hinting Indic fonts. Watch for other training videos in this series. More information can be found on Microsoft's typography website under the following locations.